Good morning, ma'am. Today I am going to say experiment 5, that is CPU scheduling in Advanced Operating System Lab. Uh, Coming to CPU scheduling, there are two types of CPU scheduling. First, we should know what is a CPU scheduling, and in CPU scheduling, the main aim of the experiment is to write a program for CPU scheduling based on FCFS, SJF, and round robin. And CPU scheduling is a process which allows one process to use the CPU while the execution of another process is on hold, that is in waiting state, due to unavailability of any resources like input, output, etc., thereby making full use of CPU. The main aim of CPU scheduling is to make the system while efficient, fast, and fair. Whenever the CPU becomes idle, the operating system must select one of the processes in the ready queue to be executed. The selection process is carried out by the short-term scheduler. The scheduler selects from among the processes in memory that are ready to execute and allocates the CPU to one of them. There are many benefits from this CPU scheduling. One is CPU utilization, to make out the best use of CPU and not to waste any CPU cycle. CPU would be working most of the time. Then coming to throughput, it is the total number of process completed per unit time, or rather say total amount of work done in a unit of time. This may range from 10 per second to 1 per hour depending on the specific processes. Turnaround time, it is the amount of time taken to execute a particular process, that is the time interval of submission of the process to the time of completion of the process. Coming to waiting time, the sum of the periods spent working in the ready queue, amount of time a process has been waiting in the ready queue to acquire get control on the CPU. So load average is the average number of processes residing in the ready queue waiting for their turn to get into the CPU. So response time. What is response time? Amount of time is taken from when a request was submitted until the first response is produced. Remember, it is the time till the first response and not the completion of process execution. And there are two types of CPU scheduling. One is non-preemptive and another is preemptive algorithms. Coming to scheduling algorithms, there are many scheduling algorithms, but based on FCFS, SJF, and round robin, we are implementing this CPU scheduling. And first come first serve means it is a non-preemptive scheduling algorithm. It follows first in first out method, and one ready queue will be there. FIFO strategy assigns priority to the process in order in which they request the processes, and when a process comes in, adds it a PCB to the tail of the ready queue. So this next process from head of queue. Dispatcher selects first job in the queue, and this job runs to completion of CPU burst. Running process does not give up the CPU until it terminates or it performs input output. And coming to shortest job first, SJF, that is, this is also known as shortest job next, and this is also non-preemptive and preemptive scheduling algorithms are there. Best approach to minimize waiting time, easy to implement in batch systems when required CPU time is in advance, impossible to implement in interactive systems where required CPU time is not known. The processor should know in advance how much time process will take. And coming to round robin is a preemptive process scheduling algorithm. Each process is provided a quantum, that is a fixed time to execute. So once a process is executed for a given time period, it is preempted and other process executes from the given time. Context switching is used to save state of preempted processes. And coming to algorithm for FCFS, first we start the program and then read number of processes, and then we will give burst times and arrival times. It will calculate a waiting time and turnaround time. It displays a result of first come first serve scheduling and calculate average waiting time and average turnaround time and displays it on screen and then stop the execution. And coming to SJF, first it will start the process, and similarly it will take an array, and it will we enter number of elements to be inserted and then select shortest burst times, and then it will follow FCFS from there. And coming to round robin, the queue structure is ready queue, like first in first out type. A fixed time is allocated to every process that arrives in the queue. This fixed time is known as time slice or time quantum, and the first process that arrives is selected and sent to the processor for execution. If it is not able to complete its execution within the time quantum provided, then an interrupt is generated using an automated timer. The process is then stopped and it's sent back at the end of the queue. However, the state is saved and context is thereby stored in memory. This helps the process to resume from the point where it was interrupted. The scheduler selects another process for the ready queue and dispatches it to the processor for its execution. It is executed until the time quantum does not exceed. The same steps are repeated until all the processes are finished. The round robin algorithm is simple and the overhead in decision making is very low. It is best scheduling algorithm for achieving better and evenly distributed response time. And coming to program, first we import packages, and then this is the class FCF, and this is the class called FCFS, and this is the main public static void main where throws exception, and these are the and int float input stream buffer, input stream reader, and buffer reader. These are the objects that we created. And system.out.println, first we are entering how many number of processes we need, and then we are giving assigning burst time, waiting time, turnaround time, and average time. So then we enter burst time for each process, and then we enter burst time for every process, and then we enter arrival time for every process, and then we enter um, and then it will produce a result like what is the burst time, waiting time, and turnaround time. It will display the average waiting time as output. And coming to output, first we enter how many number of processes. I entered it as 4, and then it will ask the burst time for each process, and then enter burst time for process 1. I entered it as 21, and burst time for process 2 I entered it as 6, and burst time for process 3 it is 3, and burst time for process 4 it is as 2. And arrival time I give process 0 as 0, process 1 as 1, process 2 as 2, and process 3 as 3, and it produces an output as a process. This is the process 0, process 1, process 2, process 3, and these are the burst times, and these are the waiting times, and these are the turnaround times. And last we find out what is the average waiting time, that is calculated as 17. It is built successfully. So coming to SJF, these are the packages, import statements. Import statements are the packages in Java programming. So this is the class we used for SJF. And coming to next main, and then after main we initialized burst time, process, waiting time, turnaround time, and we used a temporary variables and average waiting time, average turnaround time. And coming to this, first we enter how many number of processes, and we initialize all these process, burst time, waiting time, turnaround time, and then we enter burst times, and then it will produce an output. It will sort by position, and it will use a sorting technique like a temporary variable equal to burst time, and burst time equal to burst time of position, burst time of position equal to temporary variable. And then similarly it uses for process also. And first we have a 0 waiting time, and then we calculate a waiting time, for this, and we calculate average waiting time, and then lastly we calculate average turnaround time. So by this we will get an output like first we enter how many number of processes we need. I entered it as 4, and then burst times for process 1 21, process 2 3, process 3 6, and process 4 2. And these are the processes that will execute according to a burst time. So shortest job first is whichever is having shortest burst time, that process will execute first. So it took as first 2, and second 3, and third 6, and lastly it took a largest burst time that is having, that is 21. And um, and calculates average waiting time and average turnaround time. And coming to round robin, these are the packages used in round robin, and this is the class, and this is the main function, and these are the variables used initialized in round robin. Time quantum is compulsory. We should give some value and enter number of process. First we are entering number of process, and we are initializing everything, and we are entering burst time, and then we are giving enter time quantum. Based on the time quantum only, round robin will mostly depend round robin mostly depend on time. And we are using do while loop, and this is the do loop. For in do we are using for loop and if loop. And then we are we will collect we will calculate what is the process burst time, waiting time, and turnaround time, and then and displays what is the average waiting time. So coming to the output, we will enter how many number of process, that is 4. Enter burst time for every process. For process 1 21, process 2 3, process 3 6, and process 4 2. And we are entering how much time quantum we need. I gave it as 5. So for process 0 process for process and burst time, waiting time, and turnaround time, it displays in this way: process 1, process 2, process 3, process 4. This is the burst times, and this is the waiting time, and this is the turnaround time. Then it calculated average waiting time and average turnaround time, and this is about a CPU scheduling based on FCFS, SJF, and round robin. So by this way, it will implement CPU scheduling. Thank you.